The steps for solving exponential equations. Make sure the bases are the same. If they aren't, we'll change them into the same base. But then we're going to use properties of exponents to simplify each side of the equation. You can't solve the equation until you have only one term per side. So you use these properties that we just reviewed to simplify it until you have only one term on each side. Then rewrite the equation so that both sides have the same base. Then drop the bases and set the exponents equal to each other. That is hard to read. And then solve the equation. So when we look at the first one, hang on. I don't like it when it has my hand on there. We're going to look at the first one. It's already set so that there's only one term per side, and the bases are already the same. Both bases are equal to 2. So that puts us at step 4, which says we drop the bases and we set the exponents equal to each other. So x is equal to 8. X plus 1 equals 9. Those are the exponents. We set those equal to each other. Subtract the 1, and the answer is x is equal to 8. So you try the one on the right. It's already one term per side. The two bases are already both 5, so they're the same. So set those exponents equal to each other and solve for n. So you're going to set the exponents equal to each other. 4n plus 5 equals n minus 7, and solve for n. So what did you get for n? Yes. N is negative 4. If you didn't get n is negative 4, check your work. You subtract the 5 to the right, you get negative 12. You subtract the n to the left, you get 3n. Negative 12 divided by 3 is negative 4. Okay, so looking at the next one on the left, we now have two terms on the left side. So we have to use the exponent rules and make it so that there's only one. So both of our bases are 3 and we're multiplying. So what do you do with the exponents when you multiply bases? Add them. So we have k plus 2. So k plus k is 2k plus 2. And then on the right side, we still have 3 to the 5k minus 1. Our bases are the same, so we drop the bases. 2k plus 2 equals 5k minus 1. I didn't understand your question, Christian. Oh, no. And then solve for k. So k is equal to 1. Did you get k equal to 1? Add the 1 to both sides. Subtract the 2k from both sides. 3k is equal to 3. Divide by 3. K is equal to 1. Now, I'm intentionally skipping some steps on these for slightly because I want us to go quickly. But more importantly than that, I want you to start getting to the point where some of these simple steps you can do in your head, so that you can go ahead and think through those steps. That's an important skill as you progress, as we're trying to get you from where you are right now to the end of this year. I'm trying to build you up and make sure you're ready for pre-cal so that you don't struggle when you first walk in the door into pre-cal next year. Okay, so you do the one on the right. So did you get V is equal to 4? You're not supposed to read this on the computer. Did you get V equal to 4? Okay, so 9 minus 4 is 5, so you have 10 to the 5th on the left, right? Okay, so then 2V plus V is 3V, and plus 4 minus 11 is minus 7. So 5 is equal to 3V minus 7. You add the 7, which is 12, divide the 3, which is 4. Questions? Anybody still copying this one? Yeah, it looks like a couple of people are. Okay. Everybody okay with this one? All right, I'm going to leave the 2 on the front. If you need extra practice besides your practice sheet, we'll put this on and turn that off. Then, okay, so we're going to do several of these for practice. If I look at this first one, I need the bases to be the same on both sides. How can I rewrite 1/7 so that it has a base of 7?
7 over 1.
But then that would change it to 7 over 1. I need to rewrite it in such a way that it's still equal to 1/7, but it looks like 7. What do I have to do if I want to flip it over? What do I do that lets me take the reciprocal without changing the equation? Which one of those exponent rules did we just talk about? On the long sheet with your exponent rules in practice, which one of those tells you to take the reciprocal? The negative one, yes. You were on the right track. I was just trying to get you all the way down to that negative. So if I rewrite this as 7 to the 4x plus 11 is equal to 7 to the minus 1, now the bases are the same, but 7 to the minus 1 is 1/7. We aren't multiplying both sides by 7 or anything like that. We're just changing its format. So now I can say 4x plus 11 equals to negative 1. Subtract the 11, I get negative 12, and divide by 4, and I get x is negative 3. Subtract the 11 gives me negative 12. Divide by 4 gives me negative 3. Right, so any questions about what we did on that one? All right, look at the one to the right of it. Well, we need our base to be a 2. That means I need 2 to the some power is equal to 32. So 2 to the what power is equal to 32? Still too high. Not high enough. 5. Okay, the way you figure this out is you just count on your fingers. Your fingers are always with you. You're not cheating if you count on your fingers. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 5. Okay, 2 to the 5th is 32. So we rewrite this side as 2 to the 5th equals 2 to the 2m minus 9. Now our bases are the same, so we can drop out the bases. We get 5 is equal to 2m minus 9. Add the 9 and we get 14, and divide by 2 and we get 7. Does not look much like an equal sign, but 7. So, any questions about that one? Let's do the one right below that because it's combining a couple of things that we've already done. So we have 2 terms on the left. We have to combine those. So when we multiply bases, what do we do with the exponents? Add. So y plus 2y is 3y, and plus 2 and plus 5 is plus 7. Now on the right side, we need a base of 4. 4 to the what power is 16? 2. So this is 4 squared is replacing the 16, and the y minus 3 is still there as an exponent. When you raise a power to a power, what do you do with the exponents? Multiply. So the left side is still 3y plus 7, but the right side is now 2y minus 6 because we had to multiply the 2 from the 4 squared times the y minus 3. Now our bases are the same, so we can drop out our bases, and it becomes 3y plus 7 equals 2y minus 6. Subtract the 2y, subtract the 7, we get y is equal to negative 13. Questions? Are there any others? Yep, I want to look at one more together. Does everybody have, no, still copying this? Okay. So we're going, I always do that. My hand. We're going to look at this one with the 9s here on the right. So on the left side, we have 2 terms. So we multiply bases. When we multiply bases, we do what? Oh, man, I don't know what made that do that. Oh, well. We add them. So this is going to be 2x plus 2x is 4x plus 4. And on the right side, now how can we change the format of this one on the right side so that the 9 is the base? 9 to the what power? 2x plus 2x. 2x plus 2x right there. So it's negative is right, and it has a 2 on it already, so it becomes negative 2. The negative tells us to take the reciprocal, which would put it back in the denominator, and the squared would tell us it would be squared when it got there. So now you can simplify, you can solve the rest of this, right? Yes. Yes, just take the pass off my desk. I'm not set up to scan you out. We'll start doing that after the break. Okay, so you have a practice sheet, the half sheet that I gave you. This is practice. You're going to turn this in. So you'll just put your name on it and turn it in. These are matching. So you're going to use the things that we just learned with those notes, and you're going to match them to these on the right. So if you want to number and letter them, if you want to draw lines between them, however you want to do it, but these are the answers on the right to these 10 questions. So these are your practice problems, and this is what you'll turn in. The other page is your notes. Then I'm going to go ahead and put the Desmos code on the screen and from OneNote, and then you have a Desmos to do today. The one today shouldn't take you very long. It's not a matching, but it's only like 10 questions, I think. So when you are finished with that, if you did not complete the Desmos from last class, then you should have a little time left over to finish that one. And also, if you are not caught up on your current reflections, then there is one for today, and then the 2 that should already be done, you could use the little bit of time that's left after you finish the Desmos to catch up on your reflections. Yes. I told them yesterday, because some people wanted to do the Desmos because they couldn't do it at home and they could do this at home, that if you don't do that today, you just keep up with it. You'll turn it in when you come back. Yes. That is the one where I circled the problems, and everybody had to do those same problems, and then you got to choose to either do the extension on the back or the ones with the box.
It has square on it.
Yes. Yeah.
I told you I didn't have the paper because I forgot at home, but I sent you an email.
Okay, so it's probably in my email box, and I haven't processed it because I just did those. I just recorded those this morning. Yeah, I'll go and look it up as soon as I put your code up there.